Hello, everyone. My name is Aaron Sprigle,
I'm Daniel Liss.
And I'm Shtindler.
and today we're going to be showing you our entire Jurassic Park playground project. So the problem statement that we were given is that the Hoboken City Council has decreed, upon popular demand, that a playground is to be built. They hope to provide a place for our children to play and to promote healthy physical activity. So in short, we're literally just building a playground. We're using the engineering concepts that we learned throughout the semester to build a fun and safe playground. And the age range that we were given for children is children ages 5 to 12. In addition, the what that we decided on is to go with a dinosaur-themed playground set, because as we all know, children love dinosaurs.
So this is our complete design. This is our Jurassic Park. As you can see, we went with not just a dinosaur theme, but more of a prehistoric theme, with the inclusion of the Rockwall volcano. So in total, we have four of the most common staples at a playground. We have our swing set, we have our monkey bars, we have our slide, and we have our rock wall. So here's our first design, the T-Rex slide. Of course, we modeled it after a T-Rex with little arms and the tail being the slide itself. So as you can see, there's a hole in the neck of the T-Rex that leads out to the back of the slide, where you can slide down the tail. For safety measures, we added both a ladder that would keep the dinosaur upright and stable enough to climb, as well as little sides to the slide so that children wouldn't fall off the side and injure themselves. Probably our biggest structural fear would be the axial loadings on the ladder and all the loadings on the steps of the ladder themselves. Here's our second design, the only one that is not directly a dinosaur. It is our volcano rock wall. As you can see, it's in a conical volcano shape with little both dinosaur and rock handholds going up either side of it. 4 in total for on the other sides. At the top, there's a little fireman's pole that can bring the children back down through the bottom of the volcano to exit safely without fear of falling. Our most important calculations here were both on the axial loading of the fire pole and on the handholds themselves to ensure the safety of the children, because this is clearly one of our more risky, more dangerous playground equipment. Here's our third piece of equipment. It's a swing set. It looks like a pretty standard swing set in the middle, with swings, the rope going up, the bar going across. What sets ours apart are the supports. On the other side of the bar, there are 2 stegosauruses that are used as the supports. Safety here is a bit less of an issue because there isn't too big of a way children can injure themselves. We just have to calculate the stress on the ladder, on the bars, on the ropes, and on the supports themselves. But overall, this was one of our safer designs. And lastly is our Brachiosaurus monkey bars, made supposedly in the shape of a Brachiosaurus skeleton. The design is rough, but the concept there is that it looks like a skeleton of a Brachiosaurus, and the ribs that hang down are the handholds that the children are to use to climb across. Again, this was one of our riskier designs because it could break at any moment, and we had to design it in order for it not to crumble and injure the children. Our biggest fears were the bending of the arms of the ribs themselves, which could cause a child to slip and fall. But overall, these are our 4 designs.
So on to the actual calculations themselves. So first up are the axial loadings. The fire pole had a diameter of 1.5 inches, which with the weight of 1 child on it, which is 105 pounds, leads to an axial stress of 59.42 psi. And we decided the fire pole would be made out of steel, which gives us a factor of safety of 611. Next is the 2 poles supporting the ladder. So these poles had a diameter of 16 inches, which when a child is placed upon it, leads to a stress of 0.26 psi. And these would be made out of wood, which leads to a factor of safety of about 4,200. And last is the ropes for the swing set. So these have a diameter of 1 inch. And when a child is sitting on them, they have a factor of safety of, a stress of 66.82 psi. And these would obviously just be made out of rope. And so that gives us a factor of safety of 180. So next up are the shear loadings. So for this, we picked to analyze the rock wall holds and the actual rungs of the ladder. So the rock wall holds would be secured to the wall itself with a steel bolt with a diameter of 1 inch. And so if a child was entirely supporting themselves on just one hold, this would give us a stress of 133.69 psi, which when compared to the shear strength of steel gives us a factor of safety of 374. And the ladder rungs have a width of 16 inches and a height of 6 inches. So when a child is standing on this leads to a shear stress of 0.55 psi, and so a factor of safety of 183 for wood. And then lastly, these are the bending moments that we analyzed. So first one is the rung of the ladder. To maximize the moment for this, we assume that the child was standing directly in the center of this, and we have a peak moment of 420 pound-inches in the middle of it. For the monkey bar, similarly, we place the child close to the middle of it to maximize the peak moment. And for this, we found that it would have a moment of about just under 2,600 pound-inches. And then lastly, we have the gantry. And for this, we did the analysis with the children sitting in all 3 swings. And this had a peak moment of 4,200 pound-inches. And so from our analyses, we found that the materials and dimensions that we picked for our designs would all easily be able to support the weight of a child and probably could also fully take an adult. So it's overall a very safe park.
So in conclusion, the successes that we found from this project, first of all, is that we're able to qualify all of the different goals that came from our problem statement, right? So we were able to successfully build a playground, and we made it fun. At first, we were very confident in our theme, but then when we actually executed it, it turned out even better than we thought, all right? The dinosaurs were very good looking, and we believe that a child would definitely have a lot of fun. And as we said before, all of our factors of safety turned out to be very high, so we can assure you that this playground is indeed safe. Now, in terms of what we would change, at the moment, our dinosaurs aren't very detailed. They're just kind of a bare bones model. So we would definitely go back and add more detail, do some more work on the modeling and make them more aesthetically pleasing. In addition, we sort of have 4 separate playground pieces. So if we were to start from the beginning, we may want to add them all together and make a more cohesive playground in general. Lastly, as a result of this project, what we learned, first of all, is to plan ahead more accordingly. We sort of worked sporadically and did a lot of work in the moment, and we didn't get work done as efficiently as we could have. So if we planned ahead, maybe put more of a schedule out there, then the work done may have been more efficient. Last but not least, just by doing all these calculations, by doing all this work, we overall got a more general other understanding of how these materials work, their yield strengths, and just how to do the calculations in general. So with that, that has been our entire Jurassic Park playground. Thank you all so much for watching.